So let's start with week 2 again. We were talking about permutations and combinations. So we have permutations, which is in the form of NPR, and we have combination, which is in the form NCR. Okay, so let's take a very simple example. Let's say we have the letters A, B, C, and D. All right. So this is our sample, let's say. All right, this is our sample. Now we want to choose from these letters. So we have two things. We can either choose in permutation form and combination. But what does that mean? So in permutation, when we choose these letters, the order matters. Okay, so order matters. This is the most important thing. This is the main difference. Here, order matters. Here, order does not matter. Okay, that's what this means. For example, يعني, if we're looking at all of this, for A, B, C, D, the NCR will be equal to 1. And I'll explain that in a little bit. But when we come to permutation, so for P, the ways you can write this is you can write this as A, B, C, D, B, A, C, D, C, A, C, D, and D, A, C, D. All right, D, A, sorry, 1 minute. D, A, B, D, and D, A, B, C. So it's going to look like this. So C, A, B, D, and D, A, B, C. So you can see we have 4 different ways we can write it in this case. All right. More than 4, actually. Let's make the example a bit smaller so we can explain it at a smaller scale. So let's just go with ABCD or ABC. So we will have ABC. This is for permutation. ABC, then we have BAC, then we have CAB, then we will have BCA as well. All right, and CBA. So if you notice that we have 3 different ways we can write, actually one more way as well. If I pull this down, we also can write it as ACB. So if you notice, the order is all completely different here. So how many options we have? At the end, you'll notice that we have 6 different ways of writing this. So this is what we would call NPR. All right. So the way you will do this, okay, what does the N stand for? The N stands for the number of values we have that we can choose from. So in this case, we have 3. Okay, so N is equal to 3. And in this case as well, we are just simply saying that R is also equal to 3, where this is what is available. And this is what we are choosing. So in this case, we're choosing 3. So this is our R's. If you notice here, we have 1, 2, 3. We have 3 choices we are choosing. This is our R, and this is our N. A, B, C, what we are given. All right. So this is simply going to be, if we write this in the calculator, it is just going to be 3P3, which is going to give you 6. All right. And for combination, for C, none of this matters, because in the case of combination, we do not care about the order. We only have A, B, C. It doesn't matter if C is first, B is first, or A is first, as long as we have these 3 letters. So if you notice, we only have 1 choice. This is only going to be 1. This is what I mean by NCR is going to be equal to 1. So if we write 3C3, you're going to notice in the calculator, it is going to give us as 1. All right. Let's take another example, the same example. All right, the same example, but instead of A, B, we have the same A, B, C, but we only have 2 boxes. All right, 2 choices. So if we're looking at combination, all right, first of all, let's look at our N and our R. So N is still equal to 3. We have 3 things to choose from, which is A, B, and C, but R is only 2. We only have 2 boxes to fill. So if we can write this in different ways, we can write it as, in the case of combination, we can write it as A and B. We can write it as B and C. And we can write it as A and C. All right. Again, it doesn't matter if C is first or B is first or any of that. We just, what's important is that we have the choices being filled out. So how we would write it here is going to be 3C2. So it's going to be equal to, if you notice, 3 choices. You have 3 choices. So it's going to be 3C2. If you notice in the calculator, it also gives 3. All right? It's the same exact thing as we did earlier. Now, this is for combination. For permutation in this case, if you notice, we're going to write 3p2. Again, the same thing. However, 3p2, we're going to have a lot of more choices for it. Why? Because now in the same boxes, we have the same n, okay, the same r. We're going to have 2 boxes we can fill. We can write A and B as this, or we can write it as B and A, because here order is important. All right? So we can also write it as B and C, or as C and B. And the same thing for the last one, we're going to write it as C and A, or as A and C. So if you notice now, we have more options. We have 6 total options. So 3p2 is going to be equal to 6. So what is important here is order. If order is not important in the way you are choosing things, then you will be using C, which is combination, which is 3, which is just only having the numbers or the letters or the selection be selected. Doesn't matter which one comes first or not. And for permutation, order is important. So let's do an example. Let's start with the example we did from last time that we did not manage to complete, because that one is a very good way to explain. Because last time when I was explaining it, I was explaining it through the factorial method, how to do it just 3 times 2 times 1 and all of that. So if I try to find that question, it was from week 2. It was this question. Okay, so before solving this question, I just want to add one more extra point. So what does P and C mean? Yes, we type it in the calculator, we can get the number. So NPR is equal to, the formula for this is n factorial over n minus r factorial. This is the definition of how you would find permutation. And for combination, it is n factorial over n minus r factorial times r factorial. Or in other words, we can write this as it's NPR, the permutation, divided by r factorial, which is the number of choices you can have. All right. So this is just another way of defining what NPR and NCR is. Since you guys already have access to the calculator in the exam, just make sure you know how to use it in the calculator. They're the multiplication sign and the division sign when you use shift with them on your calculator. So let's look at this example again. So it says if we have 3 teachers, we have 3 teachers that must sit together. We have 4 male students that must sit together, and we have 6 female students that must sit together. All right. Okay. So we have these options. So what are the possible seating arrangements for 3 teachers, 4 male students, and 6 female students? So just to explain it, I'm going to put the boxes, but this is just for explanation. So you do not have to do it usually this way. So we have 3 teachers that must sit together. Okay. Then we have 4 male students that must sit together. So we have 4 boxes for the men. And then we have 6 boxes for the women. So 1, 2, 3, 4, 5, 6. Okay. So we'll have 6 ways of seating each one. Remember, the old method would be, so we would look at 3 of the teachers that must sit together. How would we know? We can sit any of the 3 first, then any of the 2 second, and then the last teacher will be here. Same thing for the boys. We're going to be doing 3. We have 4 boys, sorry. So we're going to be doing 4 times 3 times 2 times 1. And then for the girls, we're going to be doing 6 times 5 times 4. Oops, 5, 4, 3, 2, 1. All right. This is as I explained last time. But how would we do this in permutation and combination? So We know that the teachers must sit together, all right? Here, we are going to, the order of obviously matters because we're going to have teachers, then we're going to have students, then we're going to have, like, we cannot just select randomly, putting them in any seat. We're going to have a specific seat for everyone. So the order is very important. So the first one can be written as 3P3. What does this mean? We have three teachers to choose from, all right? And we have 3 seats available. So this is like seats available and teachers to choose from. Okay, so we have 3 teachers to choose from, and we can put them in 3 seats there. All right, just so I can explain this equation. If you notice, if we apply this equation now here, this is going to be 3p3 is equal to n factorial, n is 3 factorial, over 3 minus 3 factorial. Remember, this is n, this is r, this is n, okay? I'm just going to explain this equation one time, and then I'm not going to be using the equation again. So if we write it again, it's going to be 3 factorial over 0 factorial. Remember that 0 factorial is equal to 1. So this is simply equal to 3 times 2 times 1 over 1, which is equal to 3 times 2 is 6 times 1 is 6. So here we are going to have 6. Or in other words, it is simply just n factorial, which is 3 times 2 times 1. All right, in this specific case, because we have 3 seats allocated for each one. So it will be the exact same case for the boys. Boys, we have 4 seats, and we have 4 boys to choose from. So it's going to be 4p4. Same exact thing for the girls. We have 6 seats, and we have 6 girls to choose from. So it's going to be 6p6. The reason we have 6 seats to choose from is because if you notice, the question says, what are the possible seating arrangements for 3 teachers, 4 males, and 6 female students? So we are going to be selecting from the whole bunch. If here, for example, it said, and 5 female students, for example, if this said 5, this wouldn't be 6, this would be 5, if this case was 5. For example, but in this case, it is saying we have 6 female students we will be seating. So it is going to be all seats are available, all 6 seats. And simply, we're just going to be multiplying all of these. Now, this is only the first part of the question, all right? This is the first part of the question. If we notice here, all right, 3p3 was 6 times 4p4 is going to be 4 times 3 times 2, which is 4 times 6, which is 24, times what do we have? 6p6, 6p6, which is 6 times 5 times 4 times 3 times 2, which is 720. And we can multiply all of these. Before moving on, we are still not done with the question, because this is one of the way they can all be seated next to each other. All right. Another possible way is going to be, now if we look at the group as a whole, so we're not going to look at each number, we're just going to look at the group. So the group of teachers, then we have the group of boys, then we have the group of girls. Okay, so we're going to have a group for each one. Like, we will consider all of these as one group. So how many groups do we have? We have a total of 3 groups to choose from. So n is equal to 3. And how many choices we have? We can seat them in any way. So again, the choices is 3. We can put them either all here, or here. We can put them in any arrangement as well. And remember here, order matters, because it is important whether the blue is first, or the pink is first, or in purple, sorry, is first, or the green is first. So order matters. So we have one more additional thing for the entire group. We're going to have another 3p3. All right, does this make sense? So the idea is the seating of all of them, still the order is important. Like, yes, we already managed to seat each student, but as a group, we can also arrange their seating. Here we assume that the teachers are first, then the boys, then the girls. But we can also have the girls being first, then the teachers, then the boys, as a group. Like, they're all still sitting next to each other, the girls, but they are as a group. So this is the 3 teachers, this is the 4 boys all together, and this is the 6 girls. So as a group, we can also have an additional way of arranging each one, which is 3p3, which is going to be equal to 6 as well. So this equation is also going to be multiplied by 6 because we can see them in an additional way as a group. And then when you multiply all of these, you're going to get the answer of 622,080. This is the whole idea of how you would use permutation and combination instead of the factorial method. You can directly just use the factorial method. Yani here you could have just said, oh, we have 3 choices here, times we have 2 choices here because we selected one here already, times 1. And this is also, if you notice, is going to give us 6. But this is the entire idea. It will get complicated when you would have seating arrangements for less, like for example, for 2 teachers and only 2 male students and 6, if you want to use the factorial method. However, if you understand your permutations, you can just simply replace your R. Now that you know what R is, you can replace it instead of 3, you can put 2, 1, depending on the question. I'm going to do a few more questions with this, then I'm going to move on to probabilities. If you have any questions right now about this, please feel free to ask. I am going to do just 2 more questions about this, very simple questions, just to explain the concept a little bit better. So the question here says, we have 10 runners. Then we have 10 runners. So immediately I can say that we have 10 runners that are hoping to take part in a race. So we know that this 10 runners is our N is equal to 10. We have a total choice from 10 runners. But the track has only 5 lanes. The track only has 5 lanes. Okay. In how many ways can the 5 of the 10 numbers be assigned to the lane? So if you notice, our 5 is here. This is our 5 of the 10. This 5 is our R, is equal to 5. All right? The reason, the difference here is, how will we know if order is important or not? This you will have to understand from the question. So here it is saying the track has only 5 lanes, so our R is actually 5, okay? In how many ways can 5 of the 10 numbers be assigned to the lanes? So they want to know how many different ways we can put them. In other words, they mean order matters. In how many ways can they be assigned? So order matters. Because it is different in the case. So let's say we have 1, 2, 3, 4, 5. It is different if this is the first runner, okay? R1 we will call him, and this is R2. It's different than having it in this way, where our runner 2 is first and runner 1, because they want to know the different ways they can be assigned in all of these lanes. So because order matters, all we do now is just do 10 P5. And that is going to give us 30,240. That's it. This is how you would be doing permutations in general. You just have to understand the question, whatever order is important and order is not important. This comes a bit with logic and a bit with wording. So you have to understand الكلام يعني اللي قاعدين يقولونه. You have to just understand what it is. Let's take another example. Let's take the second question here. So in this question, it says the manager of a football team has a squad of 16 players. But we know that the whole squad N is equal to 16. All right. He needs to choose 11 to play in the match. How many possible teams can he choose? So it is important that he has to choose 11. So this is our R is equal to 11. Now the question, it's easy to identify N and R, but how do we know if it's a combination or a permutation? When you're playing football and playing in a match in a football, how many teams can be chosen? He didn't specify the order or the arrangement of these teams, these team members. He didn't specify if he wants 1 to be forward, 2 to be defense, or however way he wants to explain it, but he never specified the arrangement. He just wants 11 players. So it doesn't matter in which order. So here order does not matter. For example, يعني, if you are a group of friends, you have 20 friends and you want to choose 11 of them or whatever, it doesn't matter if you choose Ahmed first and then Muhammad second, or if you choose Abdullah first and then Isa second. It doesn't matter because they're both going to be chosen anyways. It doesn't matter who you chose first. The order of it does not matter. As long as they're in your team, that's it. So in this case, we will be using combination. So it is going to be NCR, which is the N is 16 and the R is going to be 11. So this is going to give you 4, 3, 6, 8. Tamam? That's basically pretty much it. So you have to understand from the question. The question, if it's talking about arrangement, assigned, how will they be assigned to the lanes, how many different ways, all of that, this means there's going to be a permutation if there's a specific order to it. In this case, it just says the manager wants a team. He needs to choose 11 from a random number. That's it. He doesn't care about who comes first, who comes last. So this is going to be combination. Let's do this last one, and then we will move on to probability. Let's do this. So here it says a 5-digit number is formed from the digits 2, 4, 5, 7, and 8. How many different numbers are possible? Okay, so we have 2, 4, 5, 7, 8. So how many different numbers are possible? It's very straightforward. You can simply just put the boxes. If we did this in the old method, we're going to put boxes, and then we're going to say we can choose 5 numbers here, 4 numbers here, 3 numbers here, 2 numbers here, and 1 number here. But now we know that this is order here is important because it matters if 2 is coming first or 4 is coming first. So order matters. All right, this is just for part A. So since we know that the order is important, we're just going to simply do 5p. How many choices we have? We have 5 boxes. So it's going to be 5p5, which is equal to 5 factorial as well, which is equal to 120. All right, very straightforward. Now let's look at part B. Part B, it says what is the probability that one chosen at random is odd. فيعني, what does that mean? It means what are the chances that the number you choose is going to be an odd number? How can we define an odd number? An odd number ends in an odd number. So an odd numbers are 1, 3, 5, 7, 9. So if the number ends in one of these numbers, it's going to be odd. But from our choices, we only have 2 odd numbers, which is the 5 and the 7. Okay, so we know that the first 4 numbers, it does not matter what they are. The only thing that is important is our last number over here. Okay, but the choices now are going to be different. How so? So the numbers are 2, 4, 5, 7, and 8. Okay, these 2 numbers, okay, they have one of them, at least one of, or just one of them has to be in the last box, in the red box. So how would we look at this from a permutation standpoint? So we know this is all permutation. Order is important in all of this because we're dealing with numbers. So the first boxes, we're going to treat the 5 and 7 as if they're one part. So it's going to be 2, 4, 8, and then one box for 5 and 7. Okay, 5 and 7. So we're going to have 4 choices to choose from for the first 4 boxes. Why is that? Because the last number has to it has to go in the last box. So we cannot choose from all 5 to be in the first 4 boxes. So in this case, we're going to have 4 to choose from. We have 4 over here in total. So n is equal to 4. So 4 to choose from. We know order matters, so it's permutation. And how many boxes we have? We have 4 boxes. So it's going to also be equal to 4. Now this is for just this part, the first 4 boxes. What about the last box? In the last box here, how many choices we have? We have 5 or 7. We have 2 choices. So our n is going to be equal to 2 for this one. So it's going to be 2p. We know it's going to, order is also important. We know we have 2 numbers to choose from. How many boxes do we have? We have 1 box. So r is equal to 1. It's going to be 2p1. And that's pretty much it. And then you will multiply. So in other words, it's going to be 4p4 times 2p1, and that is going to give you 48 choices. All right? This is how you would do it. You would look at the choices you have, and you have to understand the question. So the question was saying random is odd. So the odd numbers, the last digit is the only thing that affects an odd number. So this is going to be separate from the remaining. And from the remaining, you're going to consider whatever choices that can be at the end as one full block by itself, okay? As a box by itself, as a block by itself. And that will be your number of selection. And yeah, and that's pretty much it. What about the last part, part C? What is the probability that the number chosen is greater than 30,000? So again, the numbers we have are 2, 4, 8, 2, 4, 5, 7, and 8. 2, 4, 5, 7, and 8. For this part, what is important is the very first number we have. All right. The very first number has to be 3 or larger. All right. Because we want the number to be greater than 30,000. Yani when we put all these numbers inside the box, it has to be starting with the number 3, and it doesn't matter the order of the remaining ones, or it doesn't matter what numbers are in the remaining ones. So we have to look at the numbers that are greater than 3. What numbers are greater than 3 here? We have all of these that are greater than 3. So we can choose any of these numbers. So again, we're going to do 2 boxes. So it's going to be 2 and the choice of all the big numbers. So our n in this case is equal to, wait, actually, 1 minute. Before I do this, let's look at just the red box, okay? Because we're starting with the red box, and then the remaining boxes are black. Okay, let's start with just the red box so we can go step by step. The red box, we have this red selection over here. So here, this red selection, all right, n is equal to 4. Okay, the number of choices we have is 4. And what is our R? We have only one box to choose from, so R is equal to 1. So for the first box, it's going to be 4P1. Because 4 is n, we have to choose, order matters, and 1 is how many boxes we have available. So now we're left with 4 boxes. So we already know that R now is equal to 4 here for these 4 boxes. But what is our n? Our n here is going to be, we can have 2, we can have 4, we can have 5, we can have 7, we can have 8. This is our total combinations. But let's say one of these numbers is selected, the 4, 5, 7, or 8. For example, let's assume 8. So one of the numbers is selected for the first box because we only chose one number for the first box. So the first, we're going to just eliminate a number. How many do we have to choose from now? The remaining R is going to be, the remaining letter N, it's going to be 4 because we only have 4 more options to choose from because the first one, this one has already been selected here for the first box, all right? One of these numbers, it doesn't necessarily have to be 8, but one of the choices has been selected for the first box. So one choice has to be removed, and we will be remaining with 4 choices. So now we have the n is 4, order is important here, and R is also 4. And that's it. And then we're going to multiply these. So 4P1 times 4P4 is equal to 96. This is how you will use permutation and combination as a whole. I hope this clarified as much as I can the problems that we used to solve. Now you guys can like refer back to the older problems you solved and see how you can apply permutation and combinations to it. It is a very straightforward concept. It's all about understanding the question. That is the most difficult part, not the solution. The solution is just following steps. If you guys have any questions, ask them now before I move on to probability, because we're going to be closing this. Okay, let's see. Why did we use C and not P? I'm guessing you're asking about the previous question, question number 2. Again, we used C because order does not matter. When you are choosing football players, الحين انت عندك فريق 11 لاعب فيه، زين؟ او تبغى تختار 11 من 15 او من 16. مو بمهم اذا انت اخترت يعني حطيت واحد حارس او واحد هجوم، مو بمهم هالشيء لان they do not mention it in the question. It doesn't matter which order is being chosen. You just need to choose 11. Order does not matter at all who you're putting first, second, third on the list. As long as you're choosing one guy, that's it. خلاص, you chose the number 1. So that's why we used C here. And the next question, why we used P, is because the order arrangement is important. It does matter if we have the number 2 first or if we have it second. So order here matters. But why are there 4 black boxes and why not 3? Because we have 5 total numbers. So we will always have a total of 5 boxes. We have to have a total of 5 boxes. All right. يعني البوxes here we have 1, 2, 3, 4, 5 numbers to put in them. See, a 5-digit number here is mentioned. See, a 5-digit number is formed. So this way, our total number of boxes will always have to be equal to 5. Doesn't matter how many are red and how many are black. The total number of boxes have to be 5. So in this case, we have 4, and here we have 4 plus the red box, so it becomes 5. Tamam? All right. Take a breather, 2 minutes, then, so we could just conclude the combination permutation, get that out of your head. Take a minute to take a breather before we start probability, and it's a whole new concept. And then we'll start in 2 more minutes with probability. And inshallah, we will try to do our best to complete it all the way up to week 5, half of it at least. And probability is going to be very easy, inshallah. Question 10 from combinations. This one? Fine. We will do one more question. Why not? Let's do one more final question in combinations, just to maybe even help clear the point more. Now, Ahmed has a locker with 4 digits, with a 4-digit password. He can set, actually, this is a good question. So first of all, we know he has a 4-digit password. معناته we have a total of 4 boxes. Then, it doesn't matter what the numbers are, but the total of the boxes is 4. He can set the password combinations himself. In the order of preference, order matters. So in the order of preference, we know this is going to be P because order matters. He likes the numbers 1, 3, 5, 6, and 8, and 9. All right. So he likes these numbers in this order. Tamam? Only 1 digit can be used at a time, so we cannot use the same digit twice. For his password, he will only use numbers. So there's no letters. It's only one of these numbers that he will be choosing. All right. So let's look at the first question. Question A. In how many ways can different passwords be made? So we have 4 boxes. Okay. And he has 1, 2, 3, 4, 5, 6 numbers. So n is equal to 6. Okay. So very simple. N is equal to 6. You have 6 numbers here. And you have your boxes R is equal to 4. So the first one, very straightforward, is 6P4. Tamam? That's how you would do it. Clear? In another way you could do it is you could say you have 6 choices here, 5 choices here, 4 choices here, 3 choices here, and you just multiply them, and it's going to give you 360. Tamam? It's the same idea. That's the whole idea of permutation, is instead of you writing all of this and doing that, you just put one formula, apply it, and you can find it. Now, how many odd password combinations are among these? Odd, again, same idea. So let's look at the numbers we have. We have 1, 3, 5, 6, 8, and 9. All right, so this is your numbers that you can choose from. Okay, so we want to know how many possible combinations are going to be odd. Again, the number of boxes will not matter. We're going to have a total of 4 boxes, but the last digit will be important. Why is it important? Because this digit is what determines if it's odd or even. Okay, and then we will solve exactly the same way again. We were going to look at how many odd numbers we have here. We have 1 that is odd, 3 that is odd, 5 that is odd, 6, 8, 9, 9 is odd. Okay, so we have 4 odd numbers to choose from for the red box. Okay, we have 4 of these. The total number of numbers we can choose from is going to be different. Let's start with the odd number first. So we can choose from 4 numbers for the odd one. Okay, so our n is equal to 4. How many choices we have? We have r is equal to 1. So it's going to be 4p1. Okay, this is what we have for the last one, the last box. Now keep in mind when we are going to rewrite these numbers 1, 3, 5, 6, 8, and 9. صح? 1, 3, 5, 6, 8, 9. Yes. One of the odd numbers has already been chosen. So a number has already been taken away. We are remaining now with 5 numbers. So our n is equal to 5. How many choices we have here? R is equal to 3. it's going to be 5p3. And then you're just going to be multiplying these two. Let me just check my work. 5p3 times 4p1. It is going to give me, so 5p3 times 4p1 is equal to 240. And that's it. This is how you will find how many password combinations are for the odd. For even, so part C says for even now. How many even password combinations are among these? So there's two ways of doing this. There's the fast way, like I don't know if you're understanding what's happening, and then there's the same method that we just applied for part B. I'm not going to reapply part B method. First of all, how many ways can the password be made total ways? So the total ways is equal to 360. Odd is equal to 240. So the total ways have to be the odd ways and the even ways. Then these are the two possible numbers to have. You can have them as either odd or even. There's no third choice in this case. So what can we do to find the even? You can simply just subtract these two numbers and you're going to get 120 even. Tamam? If you want to check your work, you can do the same method that we did here for the odd, but for the even numbers, the 6 and 8. If you notice, the only thing that will change is the box at the end. Instead of 4p1, it's going to be, we have two choices, it's going to be 2p1. So it's going to be 5p3 times 2p1, which is also 120. All right? So another way would be 5p3 times 2p1. 120. See, if you notice, I didn't even need to draw boxes or anything to solve this. The only reason I draw the boxes is to make it easier for you guys to see it and understand it. If you guys get enough practice, you're going to look at this and you're instantly going to be able to understand where you put your P's, where you put your N's, where you put your R's, all of that. All right? And this is question 10 for you. Now, 2-minute break, just 2 minutes. زين. I'm not going to do any more combination questions. I think that's enough for now. عشان we can start with probability. I believe we can finish, inshallah, all of it, but not all of it, but up to week 5 by today. Worst case, tomorrow I will continue week 5, 6, and 7. And if there's still no time, inshallah, I will do one more revision session either on Sunday or Monday, depending on my schedule. But we will see how it goes. But for now, just take a breather for 2 minutes. I'm going to stop talking for 2 minutes. Clear your head, لأن probability has a lot of information. And once we get into probability, خلاص, يعني it's going to be a lot of things at the same time. All right, back in 2 minutes. All right, so probability. What does probability even mean when we're talking about probability? we are talking about the chance of something happening, okay? So there's a 0% chance of something happening, or there's a 100% chance of something happening, or something in between, okay? So the probability will always be between 0 and 100%, or if you write it in decimal form, it's going to be between 0 and 1, okay? There's never a chance of something happening more than 1. There's never a chance of something happening less than 0. زين؟ لأنه دائما between 0% and 100%. But what does it mean? ففرصة يعني chance of something happening. Let's take a very simple example of a coin. Okay? A coin. A coin has two faces, right? So you have two options. It's either heads or tails. زين? Very simple. Heads or tails. دائما تشوفون if you watch football, they're always flipping a coin at the beginning to see which side will start. The whole idea of this is there's a chance it will be either heads or tails. So what does that mean? معناته عندنا the probability can either be heads or tails. This is what we will call our sample space. زين? The sample space is basically all the choices that you have. So it can be either heads or tails in this case. زين? The probability will be calculated how? So the probability of heads is going to be, this is the way you will write it. So the probability of your event, usually they call it an event, what is happening. So if we want it to be heads, it is going to be equal to the probability of it happening. So how many times do we have heads in our sample space? We have it one time. And what is the total size of our sample space? It is 2. So it's equal to 1 over 2, which is equal to 0.5 or 50% chance of heads. Same thing for tails. What is the probability of tails happening? Again, we have one tails. So it's going to be 1 over 2. 2 is the total sample space. So it's also equal to 0.50, which is a 50% chance. Very easy. This is a very basic example. Now, what if I told you I want to flip the coin twice? Not just one time, I want to flip it twice. So again, we are going to look at the coin. Okay, so I'm going to flip it 2 times. Flip twice. Okay, let us look at our sample space in this case. So the first flip, so we're going to start here. Okay, we're going to have 2 options. Oops, we're going to have 2 options at the very beginning. We can have it first as heads or tails. This is our first flip. Okay, our first flip, it's either going to be heads or tails. Our second flip, we're going to have an option for each one. زين ليش؟ لأن هني this is when we flip it the very first time, we have either heads or tails. The second time, we're going to have it as either heads again or tails. يعني this is our second flip. يعني what does this mean? It means if we flip it the first time, we get heads. Then if we flip it again, we can either get heads or tails. And if we flip it the first time and we get tails, we flip it again we can get either heads or tails. ما أعرف إيش فيني, I can't write heads properly these days. إنزين? So it's going to be heads or tails. So this is going to be our sample space now. All of these options. And how can we write that? So our sample space now is going to be either we get heads and heads, which is this first one over here. Heads and heads. Let me actually color code it. So the first option is heads, heads. The second option is we get heads and tails. Okay. Heads and tails. The third option is we can get tails and heads. Okay. So tails and heads. And the last option is we can get tails and tails. So these are the total sample space that we have. We have a total of 4 possible options that can be the result of this. زين? So we have heads and heads, heads and tails, tails and heads, and then tails and tails. So our sample size, n of s, this is S, okay? If you remember from the very beginning of the session, remember when we are finding cardinality of a set, this is the same idea. We have a set here, the cardinality of the set is equal to 4, okay? The total number of options in the set, it's 4. Now, let's say we want to find the probability of getting double heads in a row, okay? So the probability of getting heads and heads, it is going to be equal to, what are we going to look at here? Heads. How many times is it repeating? It's only one time, so it's once over, what's our sample space? It is 4. So it's equal to 0.25 or 25% chance of getting heads. All right? This is an example, a basic example if you want to just get heads. This is what they call a tree diagram, which is explained in later weeks, but this is the very basis of probability. It's always easier to visualize when you draw a tree diagram for a simple, especially when it comes to coin flipping, because it's a very simple thing to look at. الحين, what if I tell you, okay, I don't want the probability of getting heads. I just want the probability of getting at least one heads. يعني, it doesn't matter which one. I just want a probability of heads. It doesn't matter if it happens in the first flip or the second flip. زين? Let's look at our options. If we look at all the options we have here, okay, let me just copy paste this down here. So this is the sample space now. After we draw our sample space, we don't really need to look at the tree diagram. We can just look at our sample space. So we have heads, tails, tails, head, and then tails, tails. This is tails, tails. I'm sorry, not tails, head. This is tails, tails. Okay. This is tails, tails. All right. Now, how many times do we see the letter H in our sample space? So at least one of them. So we have here 1. This is 1. This is 2. And this is 3. So 3 times there is a chance of getting heads. معناته the probability of heads is going to be equal to 3 divided by the total sample space, which is 4. So it's equal to 0.75 or 75% chance. This is the whole idea of probability. So the probability is how many times the event is occurring divided by the total sample space cardinality, or the total number of times of everything happening. This is the very basis of probability. Tamam? Always, I would recommend is if it is a very small question and you guys can draw the tree diagram for it, draw the tree diagram to get a better understanding, especially when it is a coin. It makes it much simpler. Let us look at this one more scenario. Let's say the coin is flipped 3 times. Coin flipped 3 times. And then the way you will draw the tree diagram for this is going to need a lot of space. So let me just do it like this. So the first flip, this is the first flip. First flip, we're going to get either heads or tails. The second flip, this is second. We're going to get either heads or tails after the first flip for heads. And the same thing here, we're going to get heads or tails. And then the third flip, this is third, we're going to get heads again or tails, heads or tails again here. For each one, we're going to have a branch or 2 branches, heads or tails. Space is running out very quickly, so let's just put this down here. Okay, so this is tails, heads, and then we're going to have again heads or tails, and then heads or tails. Okay, so if you notice here, let me try to bring this a little bit more up so it's all on the same page. If you notice here, we are going to have a total of 1, 2, 3, 4, 5, 6, 7, 8 options. So we already know that the sample, the number or the cardinality of the sample space has to be 8. Okay, the total number of possibilities is 8. And then, if we want to draw our sample space or write our sample space, we're going to look at each row by itself. So first, we're going to look at head, head, head. Okay, we're going to look at this. This is the first one. So we're going to have head, head, head. Then we're going to be looking at the second one, which is head, head, tails. Okay, so it's going to be head, head, tails. Then we're going to be looking at our third one, which is head, tails, head over here. So head, tails, head. And we'll keep going. So head, tails, tails. Then we're going to go to tails. So it's going to be tails, head, head. And then we're going to go tails, head, tails. And then we're going to go tails, tails, head. And the last one is going to be, let me just make some space. And the last one is going to be simply tails, tails, tails. Okay? This is, if you notice, all the possibilities, which is 8 different types of possibilities. Again, if any question comes, like for example, let's say we have a question, find the probability that you are going to get 2 tails. At any point, you're going to get 2 tails. It doesn't matter if it's the first, second, or third. It's just the probability of getting 2 tails. So you're going to be looking at this sample space. You're going to look at all of these, and you're going to look at the times that you are getting. We're going to look at the times that we are getting 2 tails. So the first one, it doesn't have any tails. Second one has only 1. Third one has only 1. Fourth one has 2 tails. Fifth one has only 1 tails. Sixth one has 2 tails. Seventh one has 2 tails. And eighth one has at least 2 tails. All right? So I'm saying at least 2 tails, not exactly 2 tails. So we have 1, 2, 3, 4. So it's going to be 4 divided by, this is the probability of at least 2 tails. It's going to be equal to 4, which is 1, 2, 3, 4, the red ones that we have seen, okay, divided by the total sample space of 8, which is equal to 0.5 or 50%. Now, let's say if I wanted the P of only 2 heads, for example, right? So it has to be only exactly 2 heads. It's not at least, say, 3 heads does not count. We only want exactly 2 heads. We're going to look at it again. So the first one has 3 heads total. We want only 2 heads. Here we have 2 heads. Here we have the 2 heads. Here we do not have 2 heads. Here we have 2 heads. And that's it. So we have 1, 2, 3. We have 3 over the entire sample space of 8. So it's equal to 3 over 8 is 0.375. Or in percentage, it's 37.5% chance of getting only 2 heads. And this is how you would do any probability question, okay? This is just the basics of probability, simple probability as they call it, all right? Or marginal probability, or they will also call it. What does that mean? This is when there's only one event occurring. Yani there isn't a combination or a compound event. There's only one event that is occurring at a time. There isn't more than one event that is occurring. Let's go to solving some of the basic questions that I have seen, like question 9, okay? These are very easy. I'm not going to go over it. Yani, for example, let's look at the very first one, just as an example. Insane. Week 3. Just to show you how easy these are. The first question says, what is the probability of getting an even number when a dice is rolled? So remember, dice has 6 sides, right? It can be, the sample space of the dice can be 1, 2, 3, 4, 5, or 6. Insane? Now, what are the even numbers we have? We have 2, we have 4, and we have 6. So we have a total number of 3. What is the sample size? N of dice is equal to 6. Total sample space. We have 6 elements of the sample. And that's it. So the probability of even is going to be 3 over 6. which is equal to half or 0.5 or 50%. Very straightforward. The rest of them also, it is very straightforward, these questions, but the reason I wanted to go for this question is because it uses the same example that I have explained, so it can clarify it a little bit more. So this question says 3 coins are flipped together. Then make a list of all the possible ways the coins can land. So we have already done that earlier on here. These are all the possibilities that can occur. Let me just copy paste this up here. And then, so these are all the probability that can occur for 3 coins that are being flipped. We have already identified it. So these are all the chances, which is head, 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 tails, head, tails, head, head, tails, 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 head, head, tails, head, tails, 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 head, tails, tails, tails. So the first question says, what is the probability of getting 3 tails? So I is P of 3 tails is equal to. First thing you will do always is find your N of sample space. So N of S usually. This is how I would put it down. Yani the cardinality, the number of choices you have, the number of probabilities and chances of things happening in total. So here we have 1, 2, 3, 4, 5, 6, 7, 8 things that can happen. All right, because this number will always be the same in most cases. All right. So we have 8 total numbers of things happening. The probability of 3 tails, we're going to look at them separately now. So where do we have? We only have one probability of all of them being 3 tails. So we only have a choice of 1. Okay. So the probability of 3 tails is equal to 1 divided by 8. All right. So this is the first question. The second question says 2 tails and 1 head. All right, so we want 2 tails and 1 head. P of 2T and 1H. Okay? 2 tails and 1 head. Again, you're going to go here. You're going to look at what you have, where you have 2 tails first. So none of these have 2 tails. This has 2 tails and 1 head. This has 1 tail, 2 heads. No, this has 2 tails and 1 head. This has 2 tails and 1 head. And that's it. So we have 3. Again, it's going to be the P of 2 tails and 1 head is equal to 3 divided by 8. Very straightforward. Third question says, okay, the third question says, we have at least 1 head. So P is P of at least 1 head. Make sure you understand what this means. When it says at least, معناته it's not exactly 1 head. You have to have 1 head at the very minimum, at the very least. If we look at all our options here, we have this option here has at least 1 head. Yani at least you see the letter H at least 1 time. This has a head, this has head, this, and that's it. So we have 1, 2, 3, 4, 5, 6, 7. 7 cases. So the probability is going to be of at least 1 head equal to 7 divided by the total sample size, which is 8. If you notice, they're always going to be fractions and they're always going to be less than 1 because you cannot have a probability or equal to 1 at most. You cannot have it be more than 1 because you cannot have an option that is outside the sample space. Yeah, let's say the answer is everything. It's going to be 8 over 8, which is 1. You can never have 9 out of 8 because we do not ever have a 9th chance of something happening. Okay, so it has to always be less than or equal to the sample size. Now, last part says no tails at all. So P of no tails. So we're going to look at the case that has 0 tails. The first one is the only one that has no tails because everything else has the letter T in it. So we only have 1. So again, P of no tails is going to be equal to 1 divided by our N of S, which is 8. Okay? So a general way of writing P of an event A is going to be A occurring. So when A is happening, divided by n of the S, where S, this is our sample space. Okay? This is how I usually remember it. Remember, just n of S is just like cardinality from session 1. It's nothing like to be confused about. This is just the way I write it. I don't see them writing it that way in the slides or anything, but it is the same idea. Remember set theory, same exact concepts from set theory. Now, let's solve another question. So another question I wanted to solve was this one. Okay. So a fair die is rolled. Find the probability of getting this. Remember, a dice has 6 possible options. The sample space is going to look like this: 1, 2, 3, 4, 5, and 6. All right. So the part A says a multiple of 3. All right. What are the multiples of 3? So part A, multiple of 3. So the multiples of 3 are here are 3 and 6. Remember, multiples of 3 are basically 3, 6, 9, 12. When you're multiplying 3 by 1, you get 3. 3 by 2, you get 6. 3 by 3 is 9. Or in other words, adding plus 3, plus 3, plus 3. These are the multiples of 3. So we have 2 numbers here only. So the value is going to be 2 divided by, what's our total sample space? 6. Or in other words, if you simplify this, it's 1 over 3. Part B, it says an odd number. So for part B, an odd number. What are the odd numbers we have? We have 1, we have 3, we have 5. We have a total number of 3 odd numbers divided again by the total sample space, which is 6. If we simplify this, this is 1 over 2. And part C, it says a 2 or a 6. So it's being very direct. So it wants either the number 2 or the number 6. So we have 2 options. We have the number 2 and the number 6, which are the 2 options we have, divided by the total sample space of 6, which is equal to 1 over 3. Very basic, very simple. Okay? Now, let's go to a bit more of a, it's not complicated, but it's more of an explanatory question. عشان it can explain the concept a bit more even. Now, if you roll a single die, okay, again, the same sample space, a dice has the exact same sample space, which is, oops, this is not, and where did I put part B? Oh, I put it in the wrong place. 1 second. Let me just copy paste this into week 3. Okay. So again, if you roll a single die, this is the sample space for a dice. All right. Sample space for a dice is here. Okay, 1, 2, 3, 4, 5, 6. What is the sample space for all possible outcomes? بما معنى, what is the chance for you to get a 1? What is the chance for you to get a 2? What is the chance for you to get a 3? So to get a 1, it's 1 over 6. To get a 2, it's 1 over 6. To get a 3, it's 1 over 6. They're all equal to each other. They're all equal to 1 over 6. Are the outcomes equally likely? Yes, because there's only one chance of getting the number 1. There's only one chance of getting the number 2. There's only one chance of getting the number 5. That is the whole idea. So the chance of getting any one number is 1 over 6. And then it also says what is the sample space for all possible outcomes. This is the sample space. I already showed you how to get that. Assign the probabilities to the outcomes of the sample space of part A, which I already did. Do the probabilities add to 1? This is another very important point. So 1 over 6 for the first one, plus 1 over 6, plus 1 over 6, plus 1 over 6, plus 1 over 6, 1, 2, 3, 4, 5, and one more plus 1 over 6. Remember, this is just the probability for 1, for the number 2, for the number 3, for the number 4, for the number 5, and for the number 6. When you add them all up, it is going to be equal to 1 for sure. Why is this the case? لأن the chances of everything happening has to be equal to 100%. You cannot have a probability of something that's never going to happen, and it's going to be a part of your sample space. بما معناه, when you have the sample space over here, 1, 2, 3, 4, 5, 6, then you will 100% get a number from these, get one of these. So, in other words, 1 over 6, let me just put that in the calculator very quickly. It's 0.16, yeah. So, yani 0.167 for each one. These have to all have the same addition when you're adding all of these up. 167 plus 0.167. These have to all have a chance of occurring within the sample space, and at least one of them will definitely occur. So when you're saying what is the possibility of one of these occurs, it is going to be a specific 1 over 6, but all of these are within the same sample space. So the total number of them is going to be 6 over 6, which is equal to 1. Okay? This is the whole point of the question part B. Yani you will always, when you're adding up all the probabilities you have within a specific sample space, it has to always be equal to 1. All right? What is the probability of getting a number less than 5 on a single throw? Now, يعني, again, this is very straightforward, same sample space. Let's just take this down. So this was part B. Part C, so they want the probability of when the roll is less than 5. Remember, it says less than 5, not less than or equal to 5. فمعناتها, what numbers are less than 5? We're going to look at them each. So we have 1, we have 2, we have 3, and we have 4. So we have 4 numbers that are less than 5. So this is our n. Our outcomes. We have 4 different type of outcomes. So the probability of less than 5 is going to be equal to 4 divided by a total of 6, which is 2 over 3. All right, which is 0.667 or 66.7%. All right. This is the whole point of probability. Tamam? Anyone has any questions before I go to, you know what, let's do a few more questions. We have some time. Let's do a few more questions until the concept gets a bit better. If you have any questions, you can still feel free to ask, Yani. Let me just check if anyone has nothing. So far, so good. Tamam. So let's look at this case. This I found was a very interesting question, and it's something not what we usually see. So before even finding the probability, okay, the first thing I'm gonna do is find the total space, sample space we have. So a triangular spinner has 3 sections of equal size. So these are equal in size. That's a triangular spinner. Yani it's gonna fall on one side, and you're gonna have one choice of it. The spinner is spun twice. Okay. A score found by adding the 2 numbers together. فلأن when it falls on one side, when a triangle falls on one side, then the other 2 are going to be the numbers remaining. So let us write the sample space. So the first numbers we can get are 1 plus 2, okay, which is equal to 3. We can then get 1 plus 3, which is equal to 4. We can then get 2 plus 3, which is equal to 5. We can then get and that's it. 2, 4, 5. Wait 1 second. Yeah, these are the probabilities of the very beginning. So we can get 3, 4, and 5. Now, if we want to draw the triangle for this, then so we're going to have 3 options at the very beginning. We're going to have either 3, then we're going to have 4, then we're going to have 5. Then when it falls on one side, you're going to be remaining with 2 other sides. For those 2 other sides, you're going to just add the number together. Let me just make sure that's how it is. Okay, yeah. So, what is the probability of a score of 4? Now, remember, the reason this is happening is because it's going to be spun another 1 time. So, we're going to be spinning it again over here. Okay, we're going to be spinning it again. And we're going to have 3 options again. So it's going to be 3, 4, and 5. And then again, we're going to have 3, 4, and 5. And we're going to have again 3, 4, and 5. All right. Actually, I believe this is just a simple one. It's actually just 1, 2, and 3, 1, 2, and 3, 1, 2, and 3. So let's just do it that way. السؤال بروحه it's not very clear لأن when you have a triangular side you cannot have it flat on one side. So let's keep it this way. We have 1, 2, and 3. And then we're going to have 1, 2, 3, 1, 2, 3, 1, 2, 3 for each one. And then, so we're going to have 1, 2, 3. We're going to have 1, 2, 3. And then we're going to have 1, 2, 3. So if you notice, our first option is going to be 1 plus 1, which is 2. Then 1 plus 2, which is 3. Then 1 plus 3, which is 4. Then 2 plus 1, which is again 3. Okay. Then we have 2 plus 2, which is 4. Then we have 2 plus 3, which is 5. Then we have 3 plus 1, which is 3 plus 1, which is 4. Then we have 3 plus 2, which is 6. Then we have 3 plus 3, which is 3 plus 2, which is 5, and 6. Okay. So if you notice here, we have 2, 3, 4, 3, 4, 5, and then 4, 5, 6. يعني, if I'm going to write them as a sample, we have the number 2 occurring once, the number 3 occurring twice, then we have 3 and 3, and then the number 4 occurring twice, then because we have 4 and 4, then we're going to have, actually, the number 4 is occurring 3 times. We're going to have one more 4 over here, then it's occurring here once, here twice, and here a third time. Then we're going to have the number 5. How many times is number 5 occurring? 1, 2 times. So we're going to have 5 and 5. And then we're going to have the number 6. So this is our sample space, okay? So let me just make it a bit bigger. So 4, 5, 5, 6. And then, again, all I was doing was 1 plus 1. Why? Because the question says a spinner spun twice. A score is found by adding the two numbers together. So we're just going to add all the numbers here, add the numbers, and find all the total options we have. So we have 2 one time. We have 3. Let's highlight them so I don't get confused as well. So we have 2 one time. 3 is occurring here. 1, 2. That's it. 4 is occurring 1, 2, 3. That's it. 5 is occurring 1 and 2. And then 6 is only occurring once. Okay. So these are is our sample space. 2, 3, 3, 4, 4, 4, 5, 5, and 5, 5, and 6. Okay. Now, what is our sample space, the cardinality of it? That's the first thing we need to find, n of s. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities that could occur. All right. Let's look at the questions now. So part A. What does part A say? A score of 4. All right. So we want to see how many times is 4 occurring. So we have 4 occurring here. 1, 2, 3 times. So 3 times it's occurring. So the P of 4 is going to be equal to 3 over 9. 9 is the total sample space. In other words, P of 4 is equal to 1 over 3, if you just simplify 3 over 9. Part B, it says a score of 6. So how many times is 6 occurring? 6 is only occurring one time over here. That's it. So it's only occurring one time. So P of 6 is going to be equal to 1 over 9. Okay? So 3 over 9 and 1 over 9. Tamam? Now a score of 7. Is 7 a part of our sample space? No, it is not. Okay? So P of 7 is just not possible. Or we can also say 0. but it's actually more realistically not possible. زين ليش؟ لأن never in the sample space will we ever get the number 7 with these numbers. ولا مرة you will roll this triangular spinner and you will get the number 7. So it is never going to be possible in this scenario. Is this clear? Does anyone have any questions before I move on? Okay. Now, let's solve this question because I want to explain a new point with this question. وين راح؟ First of all, let's explain this. Let's do this one, and then we'll go on to the next one. So, of 8 math tests done by a class during the year. So how many tests we have a total is 8. All right. So n of whatever our sample is equal to 8. Then that's the number of tests that has been done. So Peter has topped the class 3 times. 3 times. And he got the highest number. Peter يعني has gotten the top 3 times. It says calculate the relative frequency. What does relative frequency mean? معناته we do not necessarily have the sample size, all right? We don't necessarily need the sample size actually for relative frequency. All we need to know is that what is the total cardinality and how many times is Peter getting the top in his class, and that's it. So the relative frequency is going to be simply 3, which is the number of times Peter has gotten a good grade, divided by 8. That's it. Okay, that is how you would calculate relative frequency. It is a very straightforward concept. It does not depend on the samples directly. It depends on the sample size you have, and it depends on the number of times the frequency of someone getting a good value. يعني they did not tell us Peter has gotten A+, A+, A+. They will not necessarily mention that, but they did say he got a good grade 3 times or topped the class 3 times. فمعناته they're telling you the frequency of the matter, how many times it has happened. All right? That is basically what this question is here to explain. The relative frequency is you're not necessarily going to be given a sample size, but you're going to know the number of the sample. So you're going to be able to, or the sample space you're not going to be given, but you can. They're going to give you the sample size or the cardinality of the sample, in other words, and they're going to give you the frequency of someone basically doing that. Okay, it is very basic. It's very straightforward. يعني if I do this one as well. Okay, this question, it's exactly the same concept. Calculate the relative frequency of 8. Oops, this is not, I already did that. An unbiased coin has been tossed. When they say unbiased or fair or whatever, معناته the coin is a perfectly good coin. There's ما في يعني there isn't any messing around with the coin or it's an improper coin. It's a coin عادي يعني ربية عادية. Has been tossed 100 times. So they're telling you the frequency of how many times it has been tossed. Now, you're not going to do a diagram every time or for 100 times that is happening. Then it will take you forever to do that. But they gave you directly n of the sample space is equal to 100. And with the result 79 heads. For the number of times head has been gotten, heads is 79. That is how many times you got head when they were flipping the coin. So when you want to calculate the relative frequency, you're just going to do 79 over 100. All right? That's it, which is equal to 0.79. This is the whole idea of relative frequency. In this same question, I'm going to add another one. So it says calculate the relative frequency of the coin landing heads. Now, I will say calculate relative frequency of tails. There's one of 2 ways you can do this, okay? You can either do 100 minus 79, which is going to be equal to 21, because if this is the number of times it's heads, then this has to be the numbers of times it's tails. And if it's not heads, then it's tails. Or the proper way of doing it is if we say P of head was equal to 0.79, P of not head, if you remember from set theory, when we say something is not, معناته it is not head. In this case, not head is equal to tails. Then you only have two options. It's either heads or tails. Or, which is P of tails in this case, is going to be equal to 1 minus P of head. Okay? I'm not going to write this now. I want you guys to focus more on this equation as a whole. This is what is important. So if you have here anything that is a not, or this is how it's written as a prime, the probability of its other part is going to be 1 minus the probability of this happening. Okay, this is the concept of having the inverse or the negation or the opposite of the probability that is going to occur. All right, so it's simply going to be equal to 1 minus 0.79, which is equal to 0.21. If you want to see this in action, if we say the probability of tails, what's the probability of tails? We know the number of tails occurring is 21. We know our sample size is 100. So it's going to be equal to 0.21 as well, and they are exactly the same. Okay, so this is always going to work for not. You're always going to put 1 minus the probability of it happening. تمام؟ يعني لو أنا أقول لكم you guys have a 60% chance of passing. What is your percent chance of not passing? It's 40%. Or in other words, it is 100% minus 60%. عشان you know the percentage chance of passing. Because you are always going to look at the opposite value. You're always going to subtract it from the total possibilities, which is always going to be 100% or 1. Okay, that is the whole concept of this. Let's see this question. Now, here it says a survey of 25,000 new car buyers found that 750 had major mechanical problems in the first year. Calculate the relative frequency of having a mechanical problem. So simply, what is our n total space? It is 25000. All right? Because we have a total of 25,000 new cars. So how many of them had a problem? We had 750. So part A, having mechanical problems, so P of problem is going to be 750 divided by 25,000. So the relative frequency or the probability of it having a problem is going to be 3 over 100 or 0.03. So by logic, what is the chance of it not having a problem? Or this is just 3%. So P not problem or P of problem prime, this is the way you would usually write it, is going to be equal to 1 minus P of problem. Okay? So it is 1 minus 0.03, which is equal to 0.97 or 97%. This is how you would look at it. Yani if you do 100% minus 3%, you're left with 97%. Very basic concept, very straightforward, okay? So if you're trying to find the not of something, this is how you would do it. Now, let's take a 2-minute break, 3-minute break بالكثير, عشان we will go over the last main important concepts, which is dependent events, independent events, compound events as a whole. When we have more than one event occurring, whether they are dependent on each other, whether they're not, conditionally as well if it affects it, and then we're going to look at how it will look like in a Venn diagram. But we'll be back in 3 minutes. All right. So 2:30. We'll be back at 2:30. Just take a breather. All right. And inshallah, we'll be able to complete all of that now. So far, we have completed basically all of week 2 and 3, by the way. Yeah, I think we have just completed week 2 and 3. This is going to be now starting with week 4 and 5 together, both in one. Yani week 4 and partially 5 as well, together both in one go. All right. Actually, we did part of week 4 as well. We did the first part of week 4, which is tree diagrams, and we went over that as well. The last one. What was the last one I did? Again, I copy paste this in the wrong place. Let me just fix that. I'll re-explain it now very quickly again. Okay, so the last one, again, we have the total sample space of 25,000 new cars. The number of ones that have a major problem in them, a mechanical problem, was 750. Okay, so how do we find probability or the relative frequency in this case? You're just going to take the number of how many times it's occurring over the total sample space, which is 25,000. And you will get your part A, okay, of how many of them having problems. So not having problems is simply just going to be 1 minus of having problems. That is the only thing. In other words, you can find the total that are not having problems in the sample and calculate it that way, but no need to do all of that. Logically, if they can either have a problem or they do not have a problem. So when they do not have a problem, it is simply going to be 1 minus the probability of them having a problem, or in percentages, it's going to be 100% minus the percentage of them not having a problem. When we calculated it, we got 0.03 of them having a problem. For 1 minus 0.03 is going to be 0.97. This is 0.97. If we look at it in percentage-wise, we have 3% chance of them having a problem. 100% minus 3 is 97% chance of them not having a problem. Okay, that is the whole point. All right, just 2 more minutes and we will continue. All right. So we have now seen what simple probability looks like, or marginal probability, when it is in the case of only one, when we have only one, like one thing that will happen at a time. We don't have multiple things occurring at the same time. But what if we have more than one thing happening at a time? Now, let me explain union and intersection again. So what if we have two events that are occurring? So let's say we have event A or event B, okay? The best way to do this is, first, let's write our sample space. Sample space is going to be equal to, let's say 1, 2, 3, 4, 5, 6, 7, 8, okay? This is our sample space. And then we have the numbers 1, 2, 3, 4, 5, 6, 7, 8. Let's say event A is 1, 2, and 3. Let's say event B is 4, 6, and 8. And let's say there's an event C as well, which is 5, 6, 7, 8. 6, 7, 8. Okay. So these are all the numbers that we have. These are all the samples that we have. Now, when we are talking about combining these two, all right, when we are talking about the probability of A and B happening, or A or B happening, and all of that, we are going to have two cases. So we are going to have the case 1, which I will go over now, which is the union case. What does this mean? This basically means that P of A happening or A occurring or B occurring. And this usually means addition. All right? So let's go step by step first. So A union B, if you remember from set theory, what is A union B? A union B is going to be equal to, we just combine all of the numbers here. So we have 1, 2, 3, 4, 6, 8. This is A union B, all right, from set theory. Very basic, very straightforward, okay? And let's do A union C as well. Is equal to 1, 2, 3, 5, 6, 7, 8. Okay, this is A union B, and this is A union C. Now remember, if we do B union C, we have 4, 6, 8, 5, 6, 7, 8. Remember, when we're doing union, we are not combining them. So whatever is repeating, we will not repeat. So we have 4, then we have 6 occurring twice, we will write it once. 8 occurring twice, we will write it once. So 4, 6, 8 of B, and then we will add whatever is left from C. What is left from C? It is 5 and 7, okay? So if I just want to write this in order, it's going to be 4, 5, 6, 7, 8, okay? 4, 5, 6, 7, 8. Remember, again, when we have union, we do not look at the numbers that are being repeated, okay? So now when we want to look at probability of this occurring, we're going to be looking at the probability of this event occurring compared to the sample space that we have. So let's look at P, A, U, B. Let's look at this. All right, so AUB is given, or we found it to be this much. And the sample space is given over here as all of these numbers. So we obviously, all the numbers here are going to be a part of the sample space. How many numbers do we have? So what's the cardinality of A union B? 1, 2, 3, 4, 5, 6. We have 6. What's the cardinality of S? We have 8. Okay. So PA union B is going to be simply equal to 6 over 8, which is also equal to 3 over 4. And then this is obviously too tedious, too long. How many times are we going to have to do union A, union B, all of that? So PA union B is simply PA or B. It's the same thing of PA union B. And then, so if event A or event B is happening, it is going to be addition, which is going to be P of A plus P of B minus P A intersection B, which we will look at in a little bit. All right. So what does this mean? This means that the probability of A or B occurring is going to be equal to the probability of A occurring plus the probability of B occurring minus anything common in between them. Because remember, intersection means the common between them, something that is available in both A and B. So in this case, what is A intersection B? Or let me go back upwards. Over here, what is A intersection B equal to? If we look at A and B, A is 1, 2, 3. B is 4, 6, 8. So A intersection, there's nothing in common. So it is an empty cell, if you remember. It's phi. There's nothing in common. All right? And what is B intersection C? Or A intersection C? Again, in this case, A intersection C is also 5. Because if you notice, this is 1, 2, 3. This is 5, 6, 7, 8. Nothing in common. But B intersection C here, we do have common. We have 4, 6, 8 here. We have 5, 6, 7, 8 over here. So what are the common ones? We have 4 not common, 6 is common, and 8 is common. So B intersection C is 6 and 8. Okay? So A intersection B is phi. So the probability of it is 0. In the case of A and B, the probability here is 0. So if I just write this down again, probability of A plus probability of B minus 0. This is what they call, in the case of mutually exclusive events. What does that mean? معناته A has nothing to do with B. There is nothing common in between them. They are exclusive, mutually exclusive from each other. Yani there is no interference between A and B. Okay? All right. So if we want to find it, if we just apply this equation now, so we already know the final answer has to be 3/4. But let's apply it from this equation because it's much more direct. Because with this equation, we could just look at this part by itself. We don't have to do any other. We don't have to do all this that I have just done over here. So if I just write this down over here again and get our A, B's, and C's down here again. So if we look at the formula is P of A or B is going to be equal to P of A plus P of B minus P A intersection B, but we have already found out that this is 0. Okay? Because again, the probability of nothing happening is 0%. A and B intersection B is phi. Okay? So what is the probability of A? Probability of A, we have to first find the n of A. What is n of A? It's equal to 3. Again, what is the probability of B? First, we need to find n of B, which is also 3, because we have 1, 2, 3 chances of any of these happening out of this whole sample space. Okay, and then we have 4, 6, 8, which is 3 numbers out of this whole sample space. So the probability of A is going to be equal to 3 over the sample space 8, and the probability of B is going to be equal to 3 over 8. Same idea. Okay, obviously here I'm just doing this all in this many steps. You guys should immediately see, okay, this is 3, we have 8. Probability of A is 3 over 8. Instantly you should be able to find that. So P of A and P of B. So PA or B is going to be equal to 3 over 8 plus 3 over 8, which is 6 over 8, or 3 over 4. All right, so this is how you would solve for probability when you have 2 events occurring at the same time. It's either this event or that event that is occurring. Okay, if you notice the long method, which is also correct, but it's too long and tedious, we also got the same number, 3 and 4. And you understood this very clearly because this is just set theory. But in terms of probability, you just apply this equation. So when you have or union, it's the same meaning. You're going to do addition, and you're going to remove the common thing between them. Let's see how that will work. So we looked at A and B. Let's look at B and C. And then let's look at B and C. So we already know that probability of B is 3 over 8. Probability of C, again, we have 1, 2, 3, 4. Total number sample size is 8, which is equal to 1 over 2. Okay, so we found this. So the probability of B or C, which is also written as P, B union C, is going to be equal to P of B plus P of C minus P, B intersection C. So we have one extra thing here. We have the intersection, all right? We don't care about A. We're not going to look at A, okay? I'm going to move this a bit to the left. Okay, so we have P, we have B intersection C. We have this existing. We already have found this earlier, all right? It is equal to a sample size of 6 and 8, because those are the repeating values, 6 and 8. Tamam? B intersection C, we need to find its probability now. So what's the probability of B intersection C? Again, same idea. How many numbers we have? We have 2 out of our sample space of 8. So it's equal to 1 over 4. And now we just plug into the equation. So P of B union C, okay, is equal to P of B, which is 3 over 8, plus P of C, which is 1 over 2, minus the common 1 over 4. Now, if you notice here, when we found this using this method, the set theory method, we are already accounting for B intersection C in our union formula. Remember when we're doing union, we do not recount the repeating values. So here we only write 4, 5, 6, 7, 8. We already took that out. So this is how we accommodate for it in the probability equation. And then we have the B and C subtracted from the original one. So this is going to be equal to 3/8 plus half minus a quarter is going to be equal to 5/8. Very quick way to check. All right, since we already found B union C, where did it go? We already found B union C. All right, we found B union C. What's the probability of B union C? Since we already did the set theory for it, union C, we have 1, 2, 3, 4, 5. And what's the number of things we have in our sample space here? We have 8. So it's 5/8. See, it's the exact same thing. But you're not going to do this all the time, and you're going to do union and all of that directly. You could just do the probability directly. This is what they would call not mutually exclusive. Zin? I know they usually teach it as their separate formulas. They're the exact same formula. It's always going to be P of B plus P of C minus PB intersection C. But then you guys need to determine whether there is any common things between them or not to solve. Is this clear? Any questions about the theory? Let's see. Inshallah, the notes will be sent as soon as we're done with this session. Any questions about this? Let's solve one example or a couple of examples, and then we will go into independent events and intersection. Okay. So this is called the union method or the addition method because it is you have union U and we are adding them. So there's always going to be addition or union. Okay. Let's solve a few examples and then we'll try to also do intersection and then we can conclude today's session. So which questions was it? Yeah, over here. So look at this. Week 3. Suppose events A and B are mutually exclusive. So they're already telling you that they're mutually exclusive. So you can instantly know when it's mutually exclusive, P of A union B is going to be equal to P of A plus P of B. Very simple, okay? And they gave you P of A as 0.2, P of B is 0.65, is equal to 0.85. Very simple, very straightforward. But this the reason I wanted to show you this is how you should analyze the question. When you read mutually exclusive, معناته instantly know that there's no intersection. And then PA and PB, you're just going to add them up together because it is they're asking for union. And then that is going to be your answer. Let's look at something a bit more interesting, like this question, question 9. Then, week 3. Then. There are 10 red, 30 yellow, and 20 blue, and 10 pink marbles. So we have 10 red, 30 yellow, I'm going to use the color orange for it, 20 blue, and 10 pink, I'm going to use the purple color for it. Okay? Now, these are the total number of marbles we have in a box. So what is our sample space, our total sample space? How many number of marbles do we have? So N of S is equal to 10 plus 30 plus 20 plus 10. So this is equal to 30 plus 40, 70 marbles total. And then, so this is our cardinality. This is the total number of outcomes. A marble is drawn at random from the box. Calculate the probability that the marble drawn is, and then. So we're going to draw one marble. And then, what is the chance that the marble is yellow or red? So part A says they want the marble to be, so the probability of red or yellow or red. Just to make something clear, P A union B is equal to P B union A. Same thing later on, we're going to see P A intersection B is going to be equal to P of B intersection A. And then they're both the exact same thing. It doesn't matter which one you put first. All right. Now, so again, we're just going to apply the formula. What do we need to do? We need to find P of R plus P of yellow. And then P of R plus P of yellow. These are obviously mutually exclusive events. You don't have to put the minus P intersection B. Lena, there is no chance of yellow and red being mixed together. You know, like there's no color that is red yellow or yellowish red or something like that. They're completely different than each other. All the colors are separate from each other. They have no effect on one another. So the sample space is basically you have red, 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 and then you have yellow, 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 and then you have, so they don't have any effect on each other. And there's nothing intersecting between them. So these are mutually exclusive events. So we do not even have to put the intersection of it. So now all we have to do is find the probability of each. So how many red marbles we have? We have 10. So this is going to be equal to 10 over, what's our total sample space? 70. Plus how many yellow marbles we have? 30. What's our total? 70. This is going to be 40 over 70, which is equal to 4 over 7. Very straightforward, okay? Now it says not blue. Not blue. Part B says not blue. So P of blue not. We know that the probability of not something is equal to 1 minus the probability of that something. Probability of B. All right? So we know that B naught, okay, this is B naught. Okay, very important. This is B naught. Okay? So we can find the probability of B, and then we can instantly find the probability of not B. So probability of B is going to be equal to B has 20 marbles over total number of marbles is 70. So it's equal to 2 over 7. And then, so now if we plug this back into this equation, it is going to be 1 minus 2 over 7. So it's equal to 5 over 7. That's it. So P of not B then is equal to 5 over 7. Again, this is the same as this. Okay? This is the same as that exactly. There's nothing different. It's just the notation of it. So P naught B is the same way as writing P B naught. It's the same way. So P naught B is just 5 over 7. And that's how you can solve it. Another way, which I would not recommend of solving this, is you will add all the non-blue colors together. So you have 10, 30, and 10. So that's 10, 20, plus 30, that's 50. 50 other colors divided by 70 marbles, because these are all not blue, right? The red, yellow, and pink are obviously not blue. So you're just going to add them all up. It's going to be 50 marbles divided by 70, and you're going to get the same answer because it's not blue. It's the same exact concept. All right? Any questions about union so far? All right. All of this is saved. All of the recordings are going to be on YouTube, and the notes I'm going to be sending in the chat when we're done. Now, we are done with this. Let us... I don't want to go into intersection yet because it has its own rules and applications as well. And I want to teach you guys what conditional probability is as well. So I will save that for the next session. But I do want to go over the Venn diagrams a little bit. So in week 4, there was the tree diagram, which you guys should already be familiar with. I explained that early on. But let's take a question and draw one tree diagram before we... just to do a refresher, Yani, for a question that is slightly different. Then, so here it says the spinner below is spun twice and noted possible outcomes. So this is spun twice, 2 times. So we know we're going to have one first spin, and then we're going to have a second spin. Then, so what does the question say? Just draw the tree diagram and find the possible outcomes. So the first spin, we're going to get red. Oh, let me actually do it with colors just so there's no confusion. So the first spin, we can get red. The second spin, we're going to, or this is all the first spin. We can either get red, we can either get blue, we can either get black, or we can get green. Okay? And this is the thing. We just spin the arrow and it will land on one of them. We don't know which one. It can be red, black, blue, black, or green. And then for each and every one of these, you're going to have 4 options, which is red. This is for the first spin now, okay? We just did this for the first spin. Now let's look at the second spin. This is first spin. Now we're going to have a second spin over here. And then a second spin. Again, the first one is going to be either red, the second one is going to be blue, third one is going to be black, and fourth chance it's going to be green. And this is going to be repeated for every single one of the ones over here. Then, so this is going to be here for this one. This is going to be, it's overlapping, so let me just make some spacing. This is going to be the same thing for all the other options. It's going to be the same thing for the green. And then, so I'm just going to put this down here a bit. This is the green. Then, same thing again. It's going to be for black over here. Same thing again. It's going to be for blue. And I'm just going to keep it a bit further away because I don't have space over here. All right. So these are going to be all your options. You're going to have, if we count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we know that n of the sample is equal to 16. And if we want to write them all, it's going to be RR, RB, RB, RG, you know, RB for blue, RB for black, and all of that. So we have 16 numbers of samples. This is how you would just draw a tree diagram. I'm pretty sure you guys are all familiar with this already. We already did it with the coins. Let's solve a question that has already a tree diagram drawn for us, so you guys can see how it will be solved as well. So these are the different lunch options available for Ryan or Rayan. Sorry. Below are the probabilities of him choosing each option in the tree diagram below. So already they wrote the probabilities. So معناته you have a 0.8 or 80% chance of him choosing cheese and a 20% chance of him choosing ham. Okay, if you notice these probabilities here and here, they have to add up and equal to 1. They have to be 100%. Okay, same thing here. If you look at these two probabilities, when you add them, it has to be equal to 1. All right, these two probabilities, it's the same probabilities, and it has to be equal to 1 when you add them. Okay. So, write all the compound probabilities. So if we want to go through it very quickly, it's going to be, first option is we have cheese, apple. Then we have cheese, grapes. Then we have ham, apple. Then we have ham, grapes. We have 4 possibilities in total. Okay, 4. So n of the sample space is equal to 4. That's part A. Part B, find the probability that Ryan will choose a ham and apple. Okay, so first things first, when we are looking at this, let me just copy paste just the figure because I want to explain only the figure. When we're looking at the figure, excuse me, when we're looking at the figure, we can already, just by looking at this, instantly calculate the probability of everything that is happening on this diagram. How so? So this is what we call the probabilities of intersection. So this is probability of A intersection with B. Okay, we're only going to be looking at this very slightly now, and then I'm going to go into details about it later on with conditional probability. So probability of intersection I'm going to re-explain all of this very clearly next time, but I want to just start it up a bit so you guys have a good idea. It is going to be P of A times P of B. All right? This is, in other words, equal to, this is, I mean, only in the case of independent events. Independent events meaning the events do not affect each other in any way. Okay? يعني if you choose A first and then B, or you choose B first and then A, it does not change the outcome of the events. ما يأثر الواحد على الثاني. يعني the probability of A happening has nothing to do with the probability of B happening. So this, another way of writing it is A and B. So in this question, he's choosing a sandwich that is cheese and apple, cheese and grapes, ham and apple, ham and grapes. Okay, so we have the and in this case, which is also the intersection. You guys should know this already from set theory from the first week. Now, if you notice, it's very simple. All you're going to have to do is multiplication in this case. So in this case, it's going to be multiplication. So in union, we did addition. In this case, we're going to do multiplication. So it's going to be 0.8 times 0.6. So the probability of cheese and apple is 0.8 times 0.6. Same thing here again, 0.8 times 0.4. It's going to be 0.8 times 0.4. Same thing again here. We're going to be doing 0.2 times 0.6, 0.2 times 0.6. And the last thing over here is going to be this, 0.2 times 0.4, 0.2 times 0.4. All right? This is how you will be finding the probability for each one. So this is going to be 0.48. The next one is going to be 0.232. Yeah, 0.32. The next one is going to be 0.12. And the next one is going to be 0.08. Okay? Now, one thing I want you guys to notice again, all these probabilities over here, all of these probabilities, when you add them up, they have to give you 1, because you cannot have a chance of something not happening. These are all the chances you have of something happening. So when you do 0.48 plus 0.32 plus 0.12 plus 0.08, the answer is going to be 1, meaning that these probabilities are going to give you 100%. One of these is happening as a must. All right? And this is basically how you would solve this question. Now let's look at the probability that Ryan will choose ham and apple. So the probability he will choose ham and apple is 0.12. Okay? 0.12. Find the probability that Ryan will choose at least grapes. ما معناه he only cares about the grapes. It doesn't matter if it's cheese, if it's ham, if it's apple, it doesn't matter what's the sandwich. What's important is only his second choice. And his second choice is always going to be 40% chance of getting grapes, so it's going to be simply 0.4. And that's it. This is just a basic example. I wanted to just start this off a little bit. Inshallah, tomorrow's session, we will go. Do you guys have a session tomorrow? I don't remember if it's tomorrow or after tomorrow, but the next session, I think it's tomorrow. The next session, we will be covering all of this again, but with the newer problems. I will show you how intersection is. And then when we're done with intersection for the first hour, the second hour, I'm going to be going over the remaining parts of weeks 6 and 7. Okay? And if you guys have any questions, please feel free to ask right now. The session will be concluded.